I have a few requests to go over today's classwork, so I'm just going to take a few minutes to go over this. All right, so we're going to start out with number 1. Now, we want to determine the sign of the lead coefficient. We want to determine the degrees, whether they're going to be even or odd. We want to determine the roots, and then we're going to write a polynomial in intercept form. So let's give this a shot. Now, as far as the lead coefficient, what you want to look towards is where does your function begin and where does it end? I notice mine begins down here. And the ends, well, again, it doesn't really end or begin because there are arrows here, but you get the impression. If I look, it's going in upwards direction, which means it's going to be positive. And I can determine whether it's even or odd based on whether it's starting or ending in the same place. You'll notice that it starts down here, ends up here. If they're starting and ending in different places, you know it's going to be odd. Now to identify the roots, just look to where your function is either crossing the x-axis or approaching the x-axis. Notice right here we have -2, +1, and 3. It clearly crosses. So we got -1, +2, and +3. Now for intercept form, the first value should either be if it's negative, you would have a negative sign, but since it's positive, we can put a positive sign there, like a +1, but you don't necessarily need to. And then you're going to write an intercept form, which would mean x minus our roots. X minus -1. Yeah, I guess just got to make a little bit of space for that. Oops. X minus 2, x minus 3. And we're not asking for it in standard form today, so you don't even have to multiply it out. It'd be cool if you did, at some point, but you don't have to today. All right, now we look at number 2 here. Number 2 gets a little trickier, but I'll show you how you can navigate this. Now, it starts up here and ends down here. So since it's starting and ending in different places, I know it's got to be odd. As far as whether it's positive or negative, if you notice the general direction, it's going downwards, isn't it? Notice how it's going down? That means I would have a negative leading coefficient. As for my roots, this is where it gets a little tricky. You notice right here, it approaches -1, but it doesn't quite go through it. You get a little parabola there. That's still going to be a root. We're going to touch on this. What this refers to is multiplicity. When you have a parabola right above that root, that means you're going to end up squaring it. And I'll show you what that means. Now over here, you'll notice it goes right through +2. It goes right through. So no multiplicity here, but that is still a root. Now when I write in intercept form, since my lead coefficient's negative, I'm going to start with a negative sign. Now I'm going to start out with x minus -1, which I can write as x plus 1. But since we have a parabola there at -1, see how it doesn't cross the x-axis, but you get a little parabola? That means I'm going to square this. I'm going to square that root. X plus 1 squared. Now for the 2, again, goes right through the 2, so I don't need to square that. I get x minus 3. And that makes sense, because if you look at the degree of this, x minus 3, okay, the exponent of that would be 1. 2 and 1 indicates 3 degrees, which makes sense. When you look at this, because it's odd, goes through once here, essentially this is happening twice. That's what that parabola is indicating. So, again, remember when you see that little parabola, if it's not quite crossing the x-axis, that's when you would square that root. So we'll try another one. I'm going to scroll down a little bit. Like right here. Now you notice, starts up here, ends up here. Starts going up, ends going up. That means it's going to be an even function here. We're going to have even degrees. Now our lead coefficient is going to be positive because it ends going up, starts going up. As for our roots, you'll say approaches -2, never goes through, and we get a parabola. Same thing with 3 here. So our roots are -2 and 3. Now when I write it in intercept form, again, it's just going to be x minus your root, so x minus -2, which I can rewrite as x plus 2. But since we got the parabola there, it's not quite going through that -2. Got a little parabola, that means you're going to square it. Same thing with the 3 here. X minus 3, again, you're going to square it because You got the parabola there. It's not quite going through. See, another one that I had questions about. Did I repeat the same one twice? Oh, it looks like I did. That happens. Number 8's a little tricky. So we're going to talk about number 8. Now, first of all, starts going up, ends going up. So we know it's going to be positive. And since it starts and ends in the same place, it's going to be even. As for our roots, notice right here it goes through -3. That's definitely a root. You'll notice how when it approaches -1, it glides a bit and then goes up. Now, if you look at the end behavior notes, as far as particular functions, you'll notice that cubed functions look like this. This is what happens. They approach it, they glide, and then they go back up. So that means this one's going to be cubed. And now right here, we get the 2. You'll notice it doesn't quite go through 2. Again, we get that parabola. So for this root, we're going to square it. So that's what you want to look for. You can tell if you're going to cube it. If you get that glide, that cube behavior, where when it approaches, it glides for a little bit and then goes up. When it's squared, you notice you get a little parabola, just like so. So as for our roots, we've got -3. We've got -1. We've got +2. So how are we going to write this out in intercept form? Okay, again, it's positive. So we're going to have x minus -3, which we can write as x plus 3. We get x minus -1, which we'll write as x plus 1. But this time we're going to cube it, because again, we get that little glide. And for x minus 2, notice we get that little parabola, which means we're going to square it. So I'm just going to go back and check, make sure I don't make any mistakes here. Looks good, looks good, looks good. It's always good to go back and double check your work. So hopefully this gives you some guidance when you have to write polynomials based on graphs. Now, again, it's tough to do this. It's not an exact science. Like eventually you're going to find that you're going to be dealing with y-intercepts and stuff. It's not, it's, you know, there's going to be some error here. But in general, you just want to recognize these behaviors. You want to recognize when you're going to be squaring your root, when you're going to be cubing your root, and when your root is just going to be straight up root to the first power. All right, hopefully this helps you today.